Hi, I'm Cullen. Welcome back to Networking Fundamentals. Today we're going to cover Module 2 of Understanding Local Area Networks. Let's go ahead and review our agenda and get started. So we're going to cover Objective 1.5, Understand Network Topologies and Access Methods. In doing that, we're going to review what network topologies are, talk about Ethernet standards. These are standards that govern Ethernet communications. And also talk about peer-to-peer versus client-server models. We'll detail both of those models in contrast to one another. All right, let's move forward. Network topologies. A network topology just defines the physical connections of hosts in a network. And there are multiple types of these topologies, right? We've got bus, star, ring, and mesh. I'm going to go ahead and show you each of those right now and talk about how they function. All devices in a bus topology are just connected via copper cable and a line. So if we have a computer up on the left here, computer 1, if it wants to send data all the way down to computer, let's go 1, 2, 3, 4, 5 computers, right? So I have 5. It has to send data through computer 2, through computer 3, through 4, and then 5, and vice versa, right? So not the most efficient way to send data. Next, we also have a star topology. It's an advancement over the bus. Each host is connected to a central connecting device, like a hub or a switch or a home router, right? A SOHO router. It stands for Small Office Home Office. And this is the most commonly used topology that you're going to find in an office setting, a school setting, or even at home. Note, though, that you can actually connect two of these star topologies to each other via central connecting devices, and this type of topology is called a star bus topology. So we would connect the central connecting device to another one here that would then connect to computers elsewhere, right? And I'll just central connecting device. All right, let's keep moving. A ring topology. This is one of my favorites to draw if I'm ever in a classroom setting. Each device in a ring topology is connected to another. And note that each device is actually connected to 2 other devices. So if we have computer 1 here, it's connected to computer 5, and it's also connected to computer 2. Cool. A mesh topology is also pretty fun. One thing that I want you to note here is that there's no central connecting device. This is super important when discussing mesh topologies. This setup also requires that all computers, or each computer, is connected to all other computers within the LAN. So it can be a pretty intensive setup if you're wiring and cabling all those computers and connecting them all to each other. The great thing about a mesh topology, though, is that it's fault tolerant. So if one pathway, if I'm at computer 1 here and I want to send to, let's say, computer 2, if that direct connection between us happens to fault or something goes wrong with it, I can still send my data through multiple other connections. Maybe I want to send it down to this computer here and then back over to 2. I've got different options for sending data to its intended destination. So that's fault tolerance there. That's part of what makes the mesh topology such a great thing. All right, let's talk about Ethernet standards. So we connect all these computers to each other, all these devices to each other via copper cabling, and there are standards that govern this process. Ethernet simply is that standard, right? It defines how data is sent and received between devices. And it's the most widely used standard on the internet, so it's very ubiquitous. It's used all over the globe. There are a couple of other standards that are used, though. You've got token ring, which each device actually has to have or possess a piece of data called a token in order to be able to send data on a topology. Then you also have FDDI, which is a topology used for fiber optic communication. This Ethernet standard is governed by the Institute of Electrical and Electronics Engineers, IEEE, and it's referred to as 802.3. Devices that use the Ethernet standard transmit frames. And we had mentioned the word frames earlier, but a frame is just a sequence of bits containing a detectable beginning and end. And so here, this is a little cartoonish, and I apologize for that, but I thought it'd be funny if I actually put a frame up on the screen. Frames contain physical address information that helps switches determine where to send data. So switches don't actually send data using IP addresses. Switches send data, or they navigate data by using MAC addresses or physical addresses. We'll talk about what a MAC address here is in just a second. First, before we do that though, just a couple of quick notes. This is something that I recall being really important when I took my networking fundamentals exam. 802.3u and 802.3ab are the most commonly used versions of the 802.3 standard. Okay, so do take time to recall that, to remember that, and to lock that information in. And even if you don't, come back and review this slide later on, okay? 802.3 defines something called carrier sense multiple access with collision detection. You'll commonly see this referred to as a pretty lengthy acronym as CSMA-CD. Okay, what happens with CSMA-CD is that devices share a connection, and if they send data, then at the same time on that connection, collisions can occur. And so think of this as if you're traveling down a one-lane road, and you're driving in a car and a friend's driving in a car the opposite direction, so you guys are both driving towards each other specifically, and you couldn't peel off to the left or peel off to the right, you guys would run into each other. That would be a bad thing. That actually happens with data too. And so you could have two electrical pulses run into each other, and all of a sudden the data is corrupted and nobody ends up receiving the data, right? So that text message gets lost because something went wrong. So keep that in mind. Right. Go back to the slide here and take a quick look. The key to remember is that with CSMA-CD, only one computer can transmit data at a time. Okay. Let's talk about this collision, the CSMA-CD process. Okay. What happens is if a computer wants to use an Ethernet network using CSMA-CD, it's going to assemble a frame. It's going to go ahead and listen to an Ethernet cable to see if the medium is free. If it's free, it transmits a bit. And if it's not, then it goes ahead and it goes back and it listens, right? So if the medium isn't free, it's going to go back to checking to see if it is. And then if a collision is detected, it implements something called a collision detected procedure, which we'll detail in just a second. And if not, it just keeps sending all the bits in the frame. All right. So let's check out that collision detected procedure. What happens if there is a collision is sort of like in real life if two cars crash, right? You send out a jam signal and it stops all communication on the medium, so everything just sort of comes to a screeching halt. What happens is the computers or the devices are going to wait for a period of time that's dictated by the number of collisions that occurred, and then eventually, once the lanes are clear, once the roads are clear, it's going to start sending the remaining bits of the frame out on the network. All right, let's talk about the client-server model here, and also the peer-to-peer. The client-server model depends entirely on devices called servers, and servers are computers dedicated to providing specific types of services or data, right? So email, maybe you have a web server too. We'll detail different types of servers in just a second. Anyway, a client like your computer or like your cell phone is going to use special software to ask a server for data or those services. It's going to say, hey, can you please send me an HTML file? I would really enjoy that. And what happens then is the server provides the data or service to the client. And so this is really commonly used. You're probably using it right now, maybe to watch this video. Crazy, right? Let's talk about different types of servers, speaking of watching videos. You got file servers, print servers, database servers, network controllers. They control accounts that are on a domain. So like if you have if you're working for a school district or if you happen to be working for a company like Microsoft, there's a domain that you probably have an email address for. That means you have a user account, and network controllers are used to manage that data, that information. Also messaging servers, web servers, which are used to access HTML documents, and then also something called CTI-based servers. That's for telephone and computer systems, right? So if you have voice over IP, you're going to be probably using a CTI-based server. A couple of different operating systems here too. Like if you have a client, your client operating systems are going to be different from the types of operating systems that are used by servers. Just note the different tables there, or sorry, note the table there and the different operating systems that are used by a client and then by a server. These operating systems provide slightly different functionality, and so they serve different purposes, clearly, because clients and servers also do. All right, so a peer-to-peer model is different because it doesn't have a server. Peers are just client computers, and they all have equal capabilities and responsibilities. So each has the ability to send and receive data, or to serve and request data. And you know, it's also fairly common. We have Skype and voice over IP, like I just mentioned, and also cloud computing use the P2P model. You also may find file sharing networks like Napster, if you're old enough to remember that. I think Napster is still around, but in a very different form. You have Gnutella and then also G2. So peer-to-peer model is a little different. Each computer accesses data and requests data from its peers and not from a server. So those are two different models that you'll see in your journey through networking. All right, so just a quick recap here. 1.5, understand network topologies and access methods. We talked about different network topologies. We talked about the CSMA CD Ethernet standard and just the Ethernet standard in general. And we also talked about peer-to-peer and client-server models. So thank you so much for joining me for this module. I really look forward to seeing you next in Module 3.